Hello, everyone. My name is Alexey Korepov, and today I want to tell you about how do you make your life easier with debugging decoupled applications using OpenTelemetry. But at first, let's recall the classical approach. So just a couple years ago, to make a website, you needed just a single program in a single programming language to produce the whole website for the end users. And you need just a single instance of something like WordPress, Drupal, or, God forbid, Data Life Engine. And just a single server with Apache, PHP, and MySQL, and that's it. And for monitoring, we have just a single plaintext log file with all the logs, and we should look into it and find all the information that happened. And we had cool and convenient tools to monitor our logs. Log rotate to split our large log files per day to save space on our 40 gigabytes HDD. Then grep and awk to filter the log file. And regular expressions to be really a master. But then someone started to invent things to make our life more difficult. That decoupled approach that move part of our crucial business logic from the backend to the backend with a lot of bugs on the front-end side. That Docker that make it easy to breed the zoo of different technologies on one server. A lot of backend frameworks in different languages, Ruby on Rails, Python, Go, Node.js. And that term microservices to make everything complicated. By the way, who is that guy who coined that term that make our life very hard? And that Kubernetes that make it fashionable to breed our zoo and make it more difficult to monitor and debug. And suddenly, to monitor your application, you have to be not just a programmer, but also a system administrator, a Docker master, a Kubernetes overlord, a level 80 DevOps engineer, right? So now, any modern web application must have a good classic backend, but together with this, we also should have a separate, very complex front-end application with a crucial part of business logic. And additional backend, or even two, with different database engines. A dozen of microservices, of course in different languages too. And a third-party web service that's pretty slow and keep crashing and produce some errors. And we have to somehow monitor all this stuff, right? So, I have a lot of projects in which monitoring was a pretty tricky task. And let me show you one of the projects where we implemented a lot of things and improved this by integrating OpenTelemetry. The name of this project is Brick. It's a logistics service to calculate the optimal price of a road to deliver bricks from a factory to a construction. So just delivering bricks, just calculate the road, and that's it. But actually, to implement this, we should touch a lot of different things. And this project started around 10 years ago, and at that time, it was quite easy. So on the client side, we have just a browser which renders HTML from the server. On the server side, we had a Drupal CMS on PHP that implements all the logic and produces the rendered HTML to the browser. And we had only one MySQL database that store all the data, all the logs, and nothing else needed. And how did we monitor this at that time? Like all others, just watch our log files from engines, Drupal, MySQL, and that's it. Nothing complicated. But we couldn't live so easier. We started to think about how to be modern, and we started to invent new things. So we replaced our just HTML and browser to a Vue.js application on the front end. Then we added the OpenStreetMap tile server hosted on our server, which has a separate PostgreSQL database with PostGIS plugin. Then we added the Node.js backend for the products API with one more database on PostgreSQL. Then we added the nominating server from OpenStreetMap for reverse geocoding, which has another PostgreSQL instance with his own PostGIS plugin. Then OSRM server to calculate routes with its own format of the database. Then we found partners and started to implement integration with their API. The API is different, so we had a list of different API calls that keep crashing, changing, and so on. So a lot of problems with this. We added Redis database to speed up our application. Then we added the Solr server for faceted search of cargo bits that talks with Drupal and Node.js together. Order system we created on the new modern framework Keystone.js. And then we found out that no microservices are in our project. So we implemented the Golang microservice to parse bits from different providers and the Python microservice to synchronize products. So now we are modern with microservices. Then we added Memcache to improve speed of the Drupal CMS, and Overpass server to talk with the OpenStreetMap API with one more separate database. And step by step, our project became a real pain in 2024. So now we have more than 20 places to monitor our logs. And it's really very tricky. We need observability to see what's happening under the hood, because each component can break on or do something wrong. So what do we want usually to monitor in our application? First of all, logs. You know logs, that long boring lines with text, right? Then metrics, that CPU load, memory load, that colorful charts. And traces. Oh, traces, right. Somebody may be not familiar with this. Let me explain. So logs are just log lines with simple text to understand what's happening. And traces are like logs, but much better. Traces are the tracker of all the actions that happened under the hood after user action on the front end. So, for example, if a user click on a button on your front end application, then this query go to our API gateway, then to service A, service B, some microservices, maybe parallel queries, then to produce some queries in the database. And Trace can visualize this as a beautiful, colorful charts, and you can easily see what's happening and how much time is spent on each operation and where something is crashed or went wrong. And what tools do we have to monitor all of this? For logs, we have different tools, and here you can see logotypes of the most popular ones. And the pretty same picture for metrics, another bunch of logotypes, but there are still a lot of them. It's only the most popular ones. And the same picture for traces. So we see here different new logotypes and different vendors. So basically, we have a lot of things, and it's not easy to choose one tool that will suit for all your needs. And now I want to ask you about what vendors do you use now to monitor your applications. You can scan this core code and take part in the survey. Just type a tool that you use in your current project, like Grafana, maybe Elastic, Jagger, for monitoring, for logs, metrics, traces. So feel free to type anything. So we see 3 participants already typing. Yeah, Datadog, I know it's pretty good solution. Grafana, right? Yeah. Elastic, Graphite. Yeah, let's wait a bit. And if you already type something, you can add more brands here. And also, you can use the service to start typing questions. And we will discuss these questions at the end of the presentation. Oh, I see a lot of things. FG, new brand. Yeah, let's wait a bit more. And I see that Grafana is the most popular one. Prometheus, Elastic, Jagger, Datadog. Okay, let's wrap up this survey. Oh, 7 participants is typing. Let's wait a bit. So, okay, we gathered a lot of brands. Oh, TXT file with VS Code. Great approach. Okay, so the Grafana is the winner. Prometheus, Elastic, Sentry. Yeah, let's remember the things. Let's go next to the next slide. So as you see, already participants here use different tools, not, for example, one Grafana for all the things. So it's pretty usual picture when your backend team choose, for example, syslog-ng to store logs, Prometheus to store metrics, and Jagger to store traces. But your frontend team chosen Greylog for logs, Victoria metrics for metrics, and Sentry for traces. That's pretty often. Or maybe you are lucky, and your front-end and back-end teams work together and chosen, for example, Elastic for logs, the same Elastic for metrics, and again Elastic for traces. So what's the problem? The problem is in the vendor lock-in, because when you started to use, for example, Elastic, you started to implement integrate their libraries in all your components. And then when Elastic, for example, became too expensive or missed some new features that competitors already provide, you can't just easily switch from Elastic to Grafana. You have to rewrite a lot of things and spend a lot of time, produce a lot of bugs, and so on. Oh. Yeah, and who can help us with this situation? So we don't want to stick to only one vendor, we want the freedom, right? And the OpenTelemetry is the answer for this. So what is that OpenTelemetry? It's not a new vendor, one more vendor. It's just a collection of APIs, SDKs, and tools to collect and display telemetry data, metrics, logs, and traces. And it's free, open source, vendor agnostic, and tool agnostic. So you can feel free to use it in any project and integrate in any tool. It already provides support for a wide variety of languages, from C++, C#, Go, to PHP, Python, and even Rust. And now, with OpenTelemetry, the vendors are locked in, because we don't care about their libraries, about their APIs. We can just integrate OpenTelemetry libraries, and that's it. But someone may complain that they write in Haskell, and for now, OpenTelemetry doesn't provide a library for this. But, for example, Jagger provides a library for Haskell. And for such hard cases, we also have a solution, the OpenTelemetry collector. This is a tool that can receive data in format of different protocols. So not only with OpenTelemetry protocol, but with Jagger, Prometheus, and other popular tools. Then it can process this data and use scrubbing, normalization, batching, sampling. So modify your data, remove, for example, some private data from there, and then can export. And export not only to the OpenTelemetry storage, but again to Jagger or statsd for Datadog. And a lot of vendors already introduce native support for OpenTelemetry, so you can integrate the OpenTelemetry library and submit data to any of these vendors without any problems. And some of the vendors can already receive metrics, traces, and logs together to one place. For example, Dynatrace, Grafana, Elastic, Datadog, and New Relic. But it smells like vendor lock-in again, but actually not. You can jump to another vendor in any time without a single change in your project. So just change the endpoint from, for example, Dynatrace to New Relic, and you're sending data already to another provider. Or you can even mirror data, for example, send it to 2 or 3 or more places at once. And now I think it's a good time to show you an example. But we have to choose one of the vendors. For example, from this list, let's choose Grafana, because it's free and open source and can be self-hosted on your home server under your bed. And let's try to cram that OpenTelemetry into our project. Oh, no, not that project, to a pet project. Let's imagine that we are crypto investors and developed a cool project with AI and bots that raise a lot of Bitcoins for us. Let's name it Bitcoin. Here's how it looks, just one gold button to make money and results of work of our bots. Let's look what we have under the hood. On the clean side, we have JavaScript frontend application on Vue.js. On the server side, I used a pretty old backend on Drupal framework with the REST API. And also a microservice on Go that get crypt rates from a third-party API using an HTTP call. And an AI microservice to predict the future rates and trends, because all new startups should use AI to be modern. And I implemented 6 magic bots on Node.js as microservices that do the main job to raise money. And look, we have an elephant here, a gopher, a snake. We got a zoo. Great. And here is the dependency chart. So our front-end application sends a request to PHP backend. Then PHP backend calls a microservice on Go that calls the third-party API that can be slow or can easily go down. Then it sends data to a Python microservice to predict the future and control our Node.js bots to actually raise a lot of cryptocurrency. Now we know how it works, so let's brace ourselves and click on this gold button. And that's it. Bots updated successfully, and we raised a lot of money. Great. So let's compare how the process for making money works without OpenTelemetry and with OpenTelemetry. So without OpenTelemetry, we have this message, bots updated successfully, and the result of how many money we raised. And with OpenTelemetry, we have the same message, bots updated successfully. So what's the difference? OK, maybe let's try again. Clicking on the make money, and oops, something went wrong. So what should we do in this situation? Usually, we should call to a support engineer, right? And tell him that something went wrong, please fix this. And what the support engineer can do with this situation and this information? It will call to our front-end programmer and say, something went wrong, please fix this. Front-end programmer will look into his logs and find nothing. He will call to our PHP programmer and ask, please read your logs and find some error or what's happening. PHP programmer will find nothing, and he will call to a Go programmer, to a Python programmer, and wake up even Node.js programmer, and ask all of them to look into logs and find the real source of the problem. And finally, our Node.js programmer will find some error and spend some time and will fix it. And it will directly report to our support engineer that the problem is fixed. And support engineer will tell us, OK, it's fixed, and you can try again. And let's compare this process with the same situation when we have the OpenTelemetry. With OpenTelemetry, together with the oops, something went wrong message, we will receive the error code, this pretty long line with some random characters. Actually, it named the trace ID, and it's a unique identifier of each operation. And having this, what should we do? As usual, we should call to our support engineer, right? And say that, oops, something went wrong, please fix. And our support engineer will call to our front-end programmer, right? But no. He will ask us to give him the error code. And using this error code, he will look into the OpenTelemetry telescope and call directly to the Node.js programmer and tell, please fix the problem. But what the OpenTelemetry gives to him to understand that he should wake up only Node.js programmer, not all the team? He will see it into beautiful charts. So he will take this trace ID, enter into this input box, press enter, and see this beautiful chart. Oh no, they are sucking us to the dark side. Let's get back to the right side. Yeah, now it's better. So our support engineer will see this chart, and we can find here all our operations that happened after the user click. So here we can see our application and the event make money click that indicates that someone clicked on the button. Then the Act application started to do the HTTP GET request. Then PHP backend received this request and started to ask our Go microservice about rates. Our Go microservice do some calculations, then make API request to the third-party API. Then the operation went to the Python microservice with AI, and finally, our Node.js bots started to do something. And where is the problem? So the problem is, we see the red icon here that indicates that something went wrong with bot number 4. And actually, we can click on this line and see the pretty detailed information about what's happened. So we can see the exact date, time, and time of this event, but also we can see the actual exception with the exception message, and even we can see the name of the file and the exact line in the code in which this exception happened. And using this information, our support engineer can call directly to the Node.js programmer because he sees that this is actually the Node.js bot, not the Python or Go microservice. And even tell him about the exact place where the Node.js programmer should fix the problem. So our Node.js programmer just quickly make the fixes, deploy them to production, and report that all is fixed. Please try again. And that's it. Pretty easy, much easier, and the rest of the team can sleep well. So now the problem is solved. So let's try to click again. Now all should work well. And OK, clicking. Let's wait a bit. A bit more. Come on. Yeah, bots updated successfully. So the problem is fixed, but now it's worked quite slow compared to the previous one, right? What should we do in this situation? Let's open the DevTools of the browser and see that the actual response took more than 20 seconds. That's very slow. And what should we do in this situation? We can open the headers of the response and find there our trace ID. So if the error happened, we can display this trace ID to the end user. And if all is working correctly, we just hiding this in trace response. But if you need, you can display it for the end users too. So from the trace response header, we can find this trace ID. And using it, we can easily find the visualized trace of the operation. And here we see that actually the Python AI microservice went slow and took more than 20 seconds, and all other components worked pretty quick. We can, as usual, click on this line, and because no error happened, we see no exception there. But we can look into logs. Let's click on this button, and actually no logs found, because nothing unusual happened, just a slow response, nothing, nothing to write about it to logs. What should we do? What we have? We have also metrics. In Grafana interface, you can connect your traces with metrics using the configuration and choose the metrics that you want to connect. For example, I've chosen the CPU, memory, file system reads and writes. And after this, by clicking on the icon, we have an extended menu where we can choose any metrics that you want to look to understand what's happening in the pod, in the server, on the third-party API. So feel free to configure for your specific situation. So for now, let's click on the CPU. And yeah, look, CPU was on fire. So all our 4 CPUs was busy for 100%. And actually, our Python AI pod is indicated as a red line. And it is not a reason of the busy server. But the green line is actually the pod of our neighbor, because he asked us to share the home server with us for a couple of beers. And exactly his pod is causing problem with our production service. So that was not a good idea to share the server with our neighbor. So let's kick our neighbor from our server, and all should work well. Let's click on Make Money. And yeah, bots updated successfully less than a second. And even if all worked well, we can still get the trace ID and look how good it went. So we can open the response headers, get the trace ID, and see the picture like this. So for now, our Python AI microservice took 140 milliseconds instead of 20 seconds. That's much better, right? And that's it. We resolved already 2 problems without bothering any senior level engineers, just the support engineer and Node.js programmer. And I think now you are ready to use OpenTelemetry in your project, right? But actually, I think no. Because, as usual, your programmers have no time to integrate this OpenTelemetry. They have a lot of other tasks that are urgent and the deadline is on fire, so they don't want to do anything else. But how would you estimate this task? This is one more survey. If you already closed the page, you can scan the core code again. And please tell me your feelings, how much time integrating OpenTelemetry will require from your team. It may be 1 month, 1 week, 1 day, maybe 1 hour, or maybe 10 minutes. So what are you feeling? We have 1 month. Oh, 1 week is pretty popular. Oh, we have a draw. Okay, 1 month, 1 week, 1 hour, 1 day. Okay, 1 week, pretty obvious, because week is a lot of time, and we should have enough to integrate it. Okay, we have 42 participants, and 1 week is still the most popular. Okay, let me then show you how much efforts you need to integrate this OpenTelemetry in different languages. So here is an example of integrating OpenTelemetry into front-end applications on Vue.js and into Node.js backend application. It's just 12 lines, so you don't need to modify a lot of things in your code. Just create a new SDK and start it, and that's it. And it automatically catches all the HTTP requests and all other popular things, popular calls. For Golang, it's a little bit more, 20 lines, but still not a lot to spend a week. For Python, you need no code changes at all. You need just to wrap your application using OpenTelemetry instruments, and that's it. So no code changes at all. And the same for PHP and Drupal framework. You need just to install a module and enable it, and that's it. Nothing from the code side is touched. So I think 10 minutes is pretty enough to integrate OpenTelemetry and get rid of your monitoring zoo and start to have and analyze all the information to one chart. And if you already have integration of, for example, Elastic, you can keep the old integration and start submitting to OpenTelemetry. And then when you are ready to get rid of Elastic, you can just shut down and remove their libraries and live only with OpenTelemetry servers. And actually, OpenTelemetry is not only for the program code, it's also for databases, so you can see the same traces for individual MySQL queries, PostgreSQL, MongoDB, and other databases. Also, it works for containers, for Kubernetes, Docker build kit. For services and tools, you can integrate OpenTelemetry with Nginx, Apache, Jenkins, and connect all the information from the Nginx to your microservices to see in the single chart. Mobile applications also can be integrated with OpenTelemetry, and you can submit and track all the tabs on the mobile devices and send it to your OpenTelemetry collector. Also, virtual and bare metal servers can send metrics to the same place together with all the data. So you don't need a separate storage to monitor our bare metal servers. And I think all the other things soon will be integrated with OpenTelemetry, so we will have only one tool to collect anything you want. So OpenTelemetry now is everywhere, but why not in your project? So let's recap. With OpenTelemetry, we got a universal protocol that gives us a lot of integrations for many languages and frameworks, and even for bare metal servers. We got rid of the vendor lock and can easily switch between vendors just via changing the endpoint, and even mirror all the data to 2 or even more endpoints at once. And we got, I think this is the main thing, a calm support engineer that can find the source of any problem just via a few clicks without any special programming skills. So you can get a lot of juniors that will cover 24 hours and fix all problem via just one call. And all this for free, because OpenTelemetry is open source. And for example, if you choose Grafana, you can install it on your server without any penny paid to the vendor. And that's it. So I hope you're happy with this, and you can run to start integrating this OpenTelemetry into your project right now. But please wait a bit more, and you can leave your feedback using this QR code. And if you have some questions, you can ask them now. And also, we can review questions that you asked in the slide.com web service. But as I see, no questions for now, so let's ask the audience.
Yeah, please switch to the previous slide. So we have this QR code. Please use it. We're still improving our system, so you all can vote for the talks. And we have a little less than 15 minutes until our official closing ceremony, our final raffle, and after that, the main topic of the conference, an official after party with drinks where we can discuss all the interesting topics in an informal setting. And now we have 15 minutes for formal start of the discussion. Who wants to ask our speaker about logs and traces? And please, you're welcome.
Yeah, thank you. Alexey, I actually have quite a lot of questions, so I won't ask them all. But is it safe to allow front-end applications to post trace IDs? Can they hack our system, for example, and send a single trace ID and cause a denial of service attack?
Actually, it's safe because the trace ID is just a random string, so end user can do nothing with this if they have no access to your database. So it just submits to a black hole some data, and the data contains only the information that gathered only from their computer. So if there is some private data, you can delete it using the front-end application, or even submit them to the OpenTelemetry collector and remove there.
Okay, and you shown us the traceQL filter on one of the slides. Was it there, right?
The examples of the, let me.
Yeah, what is it capable of except for searching by trace ID?
Let me find
Can you, for example, find slower traces with it, or traces belonging to a particular customer?
Let's return to the dark side. And here it is. So we use traceQL and can just put the trace ID, but also we can search by the some tags, by the duration, filter by time, by type. Also, the trace ID is unique for each component. So, for example, for the front end, this is the trace ID. But for the, for example, Python microservice, it's another trace ID, but they're connected. And if you are a Python programmer, you can filter, for example, only traces for that Python component and get rid of front-end stuff and analyze only your part of this. And it's pretty flexible, and Grafana provides good interface, and also other Elasticsearch, Datadog provides also pretty good interface to filter and find really problematic traces.
Yeah, super, thank you. To wrap it up, we introduced OpenTelemetry to Java a couple months ago, and it indeed took a week or a little more than a week because we have some older frameworks we needed to integrate. So it's not because it's hard to apply the new framework, it's because it's hard to support the old frameworks to be aligned.
Mm-hmm. But actually, it provides for the most of languages after instrumentation, so you should wrap your code by the OpenTelemetry library, and it automatically catches all the HTTP calls, all the database calls automatically without any change in your code. And it's for the most of the popular languages already implemented, and for other languages, I think this is on the go.
Hello, Victor from that team. Alexey, that's a very interesting topic. I would remind you the first slides where you show a very complex system.
Yeah.
And the difference between this case and very complex system that you have lots of logs, lots of errors, lots of things like this. And the support engineer somehow should differ different cases. And in real life, you have bugs in your backlog which you don't fix in any minute. So it means that you have some sort of white noise of these errors in your logs. And you should somehow find new cases. And that's it. How you work in this system in real life with this lots of errors, lots of traces, and things like this?
Yeah, actually, all error marks that trace by bad trace. So we can just filter all traces, for example, with MySQL database that contain errors, and compare them, for example, get the percentage. So each 5 requests produce an error. This is definitely wrong, something wrong with MySQL database. Or if Golang microservice start to produce an error every minute, you should go only to the Golang microservice at first and analyze the situation. Or if the third-party API is down, so for example, we have Golang microservice that gets cargo bits from third-party API. And if the API went down, we see that actually not Golang went down, but the API call is offline for a minute. And actually, we see that no Golang programmers should be waked up at night. Just wait or call to the API provider to fix this. So it's pretty easy to filter by component, by error type, by some. So it's like logs, but contain much more information. And logs, for example, you have a separate list of logs from Drupal CMS and separate list of logs from Golang. And you can filter them and see together the Drupal CMS and Golang as a combined list. But in trace, you should find only one error. And by the trace ID, you can get all the inner queries or all the queries that happened before from the user click. And even on the front-end application, for example, if you have a form, a multi-step form, you can start to trace, from the first click of the place order. Then we have a form. You can put events, for example, when a user typed his name, his email, his phone, then went to the confirmation. And you will see the same chart with all the events that happened in this. And if, for example, the final step is failed, you can start not from the scratch, not from the start when the user started to click on the order button, but actually start only from the backend side, because backend side is down. So you can see all the information, only the part of this that you're interested in. That's very convenient.
Please, our next question.
Hi, my name is Aitugan. So, Alexey, first of all, thank you for your dynamic presentation. So it was very, very cool. I have a question. When you have a lot of services and the old style, it's impossible to inject trace ID. Please tell strategies. How can I connect multiple services which are old style and cannot have trace ID injected? So how can I asynchronously assign trace IDs afterwards?
You can use some wrapper, for example, the same engines that will add the trace ID to the headers of the response and connect with the upper call. So you should generate the trace ID, get the trace parent. First of all, you need to get the trace parent header to understand what is the upper trace ID. Then generate the new ID and connect both of them. And if you even have no integration of some very old web service or third-party API, at least you can get the amount of time spent on this request, and if it's failed or not. So if you receive 200, it's okay. If you receive 500, something is bad. So this is an indicator of one of your old microservices went wrong.
It's not a web application. It is not a web application, and I want to use...
not a web application.
Correct. And the only way how I can analyze all of that when I collect all the events, like all the logs all together, and then how to somehow find by some particular identifier, and then create a connection, and then afterwards I synchronously inject into trace storage. Do you have any already existing services for that I can use?
We had a situation like this, and we just patched this old microservice to put the trace ID that already received from the headers to the logs. And using the logs button, we can just, let me find this.
Actually, we can discuss this complex case on after party. Let's do 2 final questions, and after that, people are waiting for us for the closing ceremony.
Okay, thank you, and I really like this presentation, but I want to continue a little bit topic from Itugan, but in a modern world. When we have tools like Apache Kafka, when we have WebSockets, when we have all async I/O happening between our application and not just synchronous API calls. What's your suggestion in this case when we are running in a Golang microservices around Apache Kafka and processing events sequentially? What's your recommendation for this case? Thank you.
For that case, for example, if you add a new item to the Kafka queue, you can just put there the trace ID, and if it will process it, for example, an hour later, because you have a lot of other tasks in the queue, you will see in the you will see in this chart. Let me find this. In this chart, you will see the additional line an hour later that it still processes your trace ID. So you already sent the response to the client. Actually, here you can see that we sent the response to the client at that time, and the front-end application received it at that time. But actually, our PHP application had a lot of actions on terminate, so it takes a little bit more time to finalize the request. And if you have some background processes, they can extend this lock, and you will see all the information related to your starting action.
Let's discuss this later in details. 2 more questions, and we are set. Please, you are first.
What does OpenTelemetry offer for logging? Classic approach is use external tools like FlyentB or FileB to collect the logs. Is there any new approach here?
So OpenTelemetry just describes the protocol, how you can collect logs, and you can run any server. For example, the same Grafana use Grafana Loki to store logs. So you have just the standard API, how do you submit logs to the endpoint. And vendors feel free to implement all the storage options and features that they want.
Nice. And the final question, please.
Hello, what backend you use for storage traces?
Actually, I use Grafana because it's very lightweight and really can be installed on the very slow home server under my bed. And it can collect logs, traces, and metrics together, but use different engines. So for logs, it uses Loki. For metrics, it uses Prometheus or Mimir, their new implementation of Prometheus. And for traces, they use Tempa. And we can compare with, for example, Elastic. Elastic is a database, and they also have implementation of the storing logs, metrics, and traces. But comparing to Grafana, it's 10 times more time, CPU, and became slow even on small pet projects. So for large projects, you should spend tons of dollars to store this.
A reasonable choice. Please, one final round of applause for our speaker. And let's go to the hall number 1.